This video is for number 17 of the Chapter 8, Section 1 practice packet. Solve for the roots and state if they are real or complex. There are multiple ways to do each of these problems. If you like the quadratic formula, you could take A and you could rewrite it in standard form and use the quadratic formula, or you could take it and solve it backwards. That's what I'm going to do with this one. I'm going to put in 0 for my y, and we are going to find what the roots are by solving for x. So the first thing we'll do here, right, is we're going to isolate the quantity. So we're going to subtract 16 from each side. Now we're going to undo the square root. We're going to undo the square by taking the square root of each side. Since we're taking the square root of a negative, this is when we used to say no solution. Now we're going to say this is going to be 4i. On the other side, we have the absolute value of x minus 2. And remember, that means that x minus 2 has to equal positive or negative 4i. And then the last thing here, we're going to add 2 across to the other side. So we're going to have 2 plus or minus 4i is equal to x. Right? So our roots here then are obviously going to be complex. That means that this parabola does not actually cross the x-axis. Okay, because we'd have a root at 2 plus 4i and 2 minus 4i. All right, let's look at b. So for b, again, you could use quadratic formula. Since this one's in standard form, though, I'm going to factor it because I can see that there are factors of 15 that add to 8. So when I do that, I'm going to end up with x plus 3 and x plus 5. We'll use our zero product property and then finish solving. Subtract 3, we're going to get x equals negative 3. If we subtract 5, we're going to get x equals negative 5. So in this case, our roots are actually real, right? So these are both real numbers. So this one has real roots. It's going to be 2 real single roots if you wanted to be specific. And then letter C, this one's similar to letter A. I'm going to solve it that way. I'm going to do 0 is equal to negative 3 times the quantity of x plus 1 squared minus 30. Let's add 30 across to each side. So we have negative 3 times x plus 1 squared on the right side and then positive 30 on the left. We now need to get rid of that negative 3, so we're going to divide each side by negative 3. So we're going to be negative 10 is equal to x plus 1 squared. And when we take the square root on each side here, again, we're going to end up with an imaginary number. Square root of negative 10 would be I radical 10. On the other side here, we'd have the absolute value of x plus 1. We'll take it out of the absolute value, which means we need positive or negative on the other side. And then we'll subtract 1. We get negative 1 plus or minus I times the square root of 10 is going to equal x. And that should be our answer for that one. So in this case here, since we have an imaginary number and a real number, again, these ones would be complex roots. If you have additional questions on any of these ones, please make sure you reach out. Otherwise, thanks for watching.